Good afternoon, everyone, and welcome. My name's Ross Virginia. I'm a faculty member of the Environmental Studies program, and it's also my pleasure to direct the Institute of Arctic Studies here at Dartmouth, which is part of the Dickey Center for International Understanding. It's a real pleasure to be able to introduce our speaker today, Dr. Eban Goodstein from the Bard Center for Environmental Policy. He's also a professor at Bard College. The talk today is co-sponsored by the Institute of Arctic Studies, the Environmental Studies program, and Dartmouth's Iger graduate program in polar environmental science. So we have a lot of people to thank for making this possible. Eban has had a very distinguished career as an environmental economist. He was on the faculty for about 20 years at Lewis and Clark and Skidmore before more recently joining the faculty at Bard. He's focused on many different dimensions of understanding the economics of the environment, ecological economics, but importantly, the interface between, for us, I think in this context, the interface between climate change, economics, and sound policy. And in particular, how one communicates science to broad audiences. How do we instill an understanding of how economics and science interact together to inform good decision making? He's very widely published, both in the scientific literature, the economics literature, but also his work has been translated very broadly to a wide audience through Time Magazine, New York Times, other news and media outlets. Eban's been drawn upon to talk about climate to many different types of audiences and people, and I think that's probably what he has the most fun doing at this point in his career. He's published the leading textbook in the area of environmental economics, and I know that it's being used this term here at Dartmouth. But he's also published a number of other books that reach out more broadly. And one of his most recent books is this. It's got a polar bear on the cover. The title is Fighting for Love in the Century of Extinction: How Passion and Politics Can Stop Global Warming. Okay, I think you see all the right words in here. Global warming, passion, politics, this is all good stuff. And so following today's lecture, we have copies of the book out in the foyer. So if you'd like to talk to Eban about his work and buy a copy of the book, we strongly encourage you to do that, okay? He's going to talk a little bit about the Bard Center, so I won't say too much about that, except that it's an active, innovative place where education, science, and policy come together in a way that is meant to make all these better and for action, for things to happen. So let's get on to today's topic. Why is the Institute of Arctic Studies interested in having Professor Goodstein here? Well, he was involved and lead author on a very important, influential study that the Pew Foundation put out about a year ago. And what this study did was try to figure out the value of the services provided by all the cold places on the planet. You know, why should we care? What is the value of ice to our lives here? And that's what he's going to talk about today. So I'm very excited he's going to be here to bring this report to life. The title of his presentation is Pricing the Arctic Air Conditioner. So please join me in a very warm welcome for Professor Eban Goodstein.
Thank you. Thank you. Okay. Well, thank you very much for having me here today. I really appreciate it. First, I want to survey how many of you are not yet 25 but will be 25 by November 3rd, 2016? That's a hard question. You're not yet 25, but you will be 25 by November 3rd, 2016. Okay, so a few of you, okay. So I got a request for you guys when we're done here towards the end of the talk. So I am director of the Bard Center. I want to just give a quick plug. We have 2 master's degree programs, one environmental policy, the other climate science and policy. I think of special interest perhaps to Dartmouth students is that we do have a 3-2 program, which instead of spending a junior year abroad, you would come and spend a junior year at Bard. And this would allow you to essentially get a master's MS degree in either climate science and policy or environmental policy with really just one additional academic semester and a long extended internship that we would help support. So if you'd like to talk to me about that after the program, please do so. We also partner with the Peace Corps and have a joint law degree. But kind of the frame for the talk is that I think we're all engaged in thinking about leadership training for the greatest generation. You know, a lot of people refer to my parents' generation as the greatest generation because they fought and won World War II and grew up in the Great Depression. But in fact, it is today's young people who have to fast become that greatest generation. So I turned 51 this year. If you're 20-something, you know, when you turn 51, it'll be the year 2040. I'll be 80. And we'll really know, at that point, we'll know the future of the Earth. I mean, we'll know how many people are going to be on the planet, but more importantly, we're going to know whether it's going to heat up 4 degrees Fahrenheit or 11 or 12 degrees Fahrenheit within your lifetime. And to put those numbers in perspective, during the last ice age, when this particular room was covered by a couple hundred feet of ice, the world was only 9 degrees Fahrenheit colder than it is right now. So the challenge is, how do we forestall in the coming decades a swing in global temperatures of ice age magnitude within your lifetimes? That's really the overarching question that I think we're all facing. And what that means for your generation is that by the time you reach my age, you have to rewire the entire world with clean energy. You have to redesign every city on Earth. You have to reimagine the global food system. You have to reinvent transportation. And in doing all that, create a new economic system, one that is profoundly and fundamentally sustainable at its core. So you ready to do that? Absolutely. It's an extraordinarily exciting time to be alive. I mean, really, you don't have to worry about what you're going to do when you wake up in the morning. It's a tremendous amount of work to be done. And I'm sure that the environmental studies program here at Dartmouth is preparing you for that. That's what we try and do at Bard as well. So the topic today is climate change. 2010 was the hottest year on record. And we had horrendous heat waves and fires in Russia, massive flooding in Pakistan, an area the size of Great Britain underwater. 2 million people, 2 million people left homeless as a consequence of that event. This was the year actually that scientists, instead of saying, you can't blame any individual extreme weather event on global warming, they started to turn it around and say, well, if the planet wasn't heating up so rapidly, what would be the probability of seeing these kinds of events? Which is a much better way to think about it. And that Russian heat wave is, with just background climate variability, less than a 1 in 1,000 chance of that occurring. And so this is exactly, NASA said, this is what global warming looks like, 2010. Of course, we had this BP oil spill. So episodes of epic proportions that are easily visible from space are related to this fossil fuel economy and addiction that we need to kick. So I'm just going to show just a few of these pictures really to set the context. I think what's emerging this year as well, I think, is an understanding that the biggest and most profound near-term impact of climate change is going to be drought. That's really going to be the thing that's going to impact us most directly and soonest. This was the theme of Mark Hertsgaard's recent book, Generation Hot. And this is an incredible series of maps that came out from NCAR this year. So just to read it, basically anything to the left of magenta here is extreme drought. All right? And if you look at the map up here in the United States right now, there's actually only one little patch here, probably in South Dakota, that would be characterized as extreme drought conditions with a baseline of 2000 to 2009. Here's a scenario that gets us to 700 ppm by the end of the century. That's really not an extreme scenario by any means. Current trajectory of emissions would get us probably much higher than that, 800 to 1,000. And just, you can see how the colors change. Essentially, what happens under this scenario is that everything to the south and west of this line goes into extreme drought. Everything from here down experiences the kind of conditions that we're seeing in South Dakota this year. I'm sorry. So, this is just a scenario. I mean, it's a modeling exercise. It's not the truth. It's not, what will happen. But it's our best guess as to the kinds of changes that we're dialing up as a consequence of engaging in this incredibly unprecedented natural experiment in which we're altering the very nature of the Earth's climate control system. So that's what's at stake. That is why you guys, the young people in this crowd, you know, in partnership with my generation, have to be the greatest generation. Here's this year. And this is a paper by Hansen that came out earlier this year. And what's interesting about this is that it was so hot this year, especially in the Arctic regions, that they actually had to add a new color to the map. Last year, you know, dark brown was as hot as it got. But this year they actually had to add hot pink to reflect the extreme warming that was experienced in the Arctic region. So essentially, everywhere up here in December was somewhere between 6 and 11 degrees C, so that's roughly 11 to 21 degrees Fahrenheit, hotter than the 1950-1981 mean baseline. So it was really hot in the Arctic this year and remains really hot. You can see that there was, you know, we did have a slightly colder than normal winter here, but the vast predominance there of red and yellow and the hot pink, you know, is, you know, reflective of the fact that 2010 was the hottest year on record. So that's a segue into the work that we did. And I won't show the picture of, I didn't show the picture of the Arctic ice cap rapidly disappearing, but I know you've all seen that. So that's really the context for the work we're doing. I mean, that heat, what that heat is doing is rapidly melting the Arctic ice cap. So last year, in February, we released a study that had been commissioned by the Pew Environmental Group to attempt to put a number on the breakdown of Arctic ecosystem services, if you will. In its frozen state, the Arctic has acted as an air conditioner for the planet. It's helped keep the planet cool. And essentially in 3 ways, as the Arctic has started to heat up, at least the 3 ways we counted, that air conditioner is starting to break down. The first way is that as the ice that previously has covered the Arctic Ocean is melting, well, it's turning from white ice to dark water. And that's a change in albedo, and we all know that white reflects heat and black absorbs it. And so you're getting a lot less, heat reflected. You're getting a lot more heat absorbed by the Earth instead of being reflected back into space. You have a similar effect with a change in snow cover in the Arctic. So you're moving from white snow to dark tundra. So we counted the albedo change from Arctic ice, the albedo change from snow cover to tundra, and then the final thing we looked at was emissions of methane as the permafrost melts from terrestrial sources. We didn't look at continental sources. All right? Just looking at those 3 things, converting them to CO2 equivalents, I'll show you what we discovered, but sort of my work as an economist was to try and put a dollar figure on the damages that were associated with the breakdown of that Arctic air conditioner. Okay? And, you know, the punchline was that, whoops, too many pictures here. All right, I'm trigger happy. The punchline was that impacts from the Arctic ice melting could cost global agriculture, real estate, insurance, farmers, water supplies, somewhere between 2.4 trillion and 24 trillion in cumulative damages by 2050. And this was the message that we tried to get across in the media. The Arctic is the planet's air conditioner and it's starting to break down, said Goodstein. Okay, so that was our soundbite that we were working to communicate to the public. And we did it basically with the hook of large numbers that emerged from our study. So it was joint with Eugenia Uskirkin at the Institute for Arctic Biology, who was our primary lead scientist, myself, and then Henry Huntington from Pew, who's also an Arctic scientist. And you know, we had this sort of intimidating sounding title, An Initial Estimate of the Cost of the Lost Climate Regulation Services Due to Changes in the Arctic Cryosphere, which sort of gave the study scientific credibility, but then we translated that into, the Arctic is the planet's air conditioner and it's starting to break down for the media, okay? So I want to talk a little bit about the process of communication and the way in which this study actually came about. And so that's me, and this is Scott Heilemann, who is the director of Arctic programs at Pew and also is very involved in a NGO called Oceans North Canada. And Scott was actually the best man at both of my weddings and a college friend. And so a year ago last November, Scott called me up and said, the G7 finance ministers are meeting in, and I apologize for anyone who speaks Inuit, but Iqaluit, I think is how you say it, Canada, which is in Nunavut on the Hudson Bay. And we need to give them a study. We need to use that meeting as a way to illustrate the impacts of climate change on the Arctic. So can you write a study with some scientists that does that? And you got a short timeline, you got 3 months. It's got to be credible, because it's going to get lots of public press and scrutiny. Can you do that? And so I thought about it and said, sure, let's do it, Scott. So we set about, we had a very short timeline to put the study together. And you may ask, why were the G7 finance ministers meeting in this tiny little Arctic village in Iqaluit, Nunavut? And the reason was, it's really cold, it's really dark, it's very far away from anywhere, so there's going to be no protesters. No protesters and really no media, or sort of not, I'm sorry, no media. No other NGOs and people vying to get the attention of the International Press Corps who will be there, right? So Scott's thinking was great opportunity, right? There's, it's not going to be a very crowded stage. We have a presence there, so it's a legitimate place that we can do some work. Now, so I want you to just keep an eye on, there's me and Scott, and there's me and Scott, okay? So my point here is that 30 years goes by incredibly fast, right? Incredibly fast. And that, again, just to reinforce, that is the time frame over which these profound transformations in our economy have to occur. And again, that is the profound leadership challenge that people, who are under 25 or around that age face. Now, that doesn't let us off the hook because, I'm going to be around for another 20 years, hopefully pushing this as hard as I can. But, it really is the energy and engagement of your generation that's going to make the difference or not. Scott's project, so just to orient you a little bit. So Iqaluit is, where is it? It's on Baffin Island, kind of right around here somewhere, I think. So this was where the G7 finance ministers were, no. Does anyone, I think it's there, yeah. And Scott's project, Oceans North, is actually working on fisheries issues. Here in the Canadian Beaufort and Lancaster Sound, which is somewhere in here, and also off of Newfoundland. But he was interested actually in using this project to cement relationships with Inuit partners. And by helping them get their message out about the way that climate change was impacting their communities, that was a good way to engage the Inuit community, in a way that would be helpful to them and that would create bridges to the project that he was involved with. So he wasn't specifically interested in climate change per se, but again, it was sort of an opportunity to do some public education that would benefit, his project. So here's the science. This is what came up with. And again, so basically we took these 3 changes in Arctic ecosystem services. So the breakdown of the ice albedo, so the flip from white ice to dark sea, We took the forcing associated with the flip from white snow to dark tundra, and we took some estimates of increased methane emissions over the century. And really all the science involved was adding those, getting estimates from the literature, adding them up. And what we did that no one else had done, or what Eugenie did, was converted those to CO2 equivalents. So they could actually, the forcing associated with that albedo change, with those albedo changes and the methane emissions could be put in a single metric and compared to something that people understand. And so when we did that, it was actually pretty shocking to us. We weren't really expecting such a big effect, but basically what we discovered was that in 2010, compared to a pre-industrial baseline, the Arctic was generating a forcing equivalent to about between 2 and 3 billion metric tons of carbon dioxide. Now, that's about 40% of US industrial emissions, roughly equivalent to 500 coal-fired power plants. So we've initiated a positive feedback already in the Arctic such that if we were to completely eliminate US emissions, let's say by the next century, the Arctic would, with no changes from today, still be pumping out kind of forcing equivalent to half of US industrial emissions. And by the end of the century, that rises to somewhere between 120% and 70% of current US emissions, given the trends that are embedded in the study. So powerful effects associated already with the breakdown of the Arctic air conditioner. And then actually, we didn't even look at seabed methane emissions from clathrates. And this was actually the week after our report came out. There was this study, Shakova et al. In Science, that led the NSF to publish this picture and kind of trying to raise some awareness about the impacts of seabed methane. So we don't have by any means all of the bad news in our study. Okay, so my job was to do the economics and try and put a number on this because, again, we were engaging the financial press corps. That's who was there. And we needed to give them a number that they could understand and engage with. That was our goal. And in general, that's a powerful rhetorical strategy for communicating about climate change is to translate it into dollars and cents, because that's something people can deal with. So I'm going to take you through a little exercise basically of how we do that. And economists have estimated a thing called the social cost of carbon, which is the cumulative damages associated from the release of a ton of carbon over, well, there's debates about the lifetime of carbon, but it's typically over a 100-year period, okay? And conceptually what you would do would be to say, if we emitted a ton of carbon today, then in 2010 it might do 0.2% or 2/10 of a penny's worth of damage. I think that's the way I'm thinking it. No, I guess it's 2 cents. Or 20 cents. 20 cents. There, I'm sorry. I'm trying to get my numbers right. So if it does 20 cents of damages globally in terms of heating up the planet, raising sea levels, causing drought, leading to greater pest infestations, disrupting agriculture, heat waves, et cetera. 20 cents this year, we're going to assume that in real terms those damages are going to grow over time so that by the year 2100 it might be doing $2.86 worth of damages. And the reason for that growth is that the impact of the damages associated with an additional ton rise over time because the planet's heating up. So a little more forcing when it's hotter is going to do more damage than the forcing that's occurring now. And so you would think that approach might be to just sum up those damages and you get $91.53 in this particular case. Of course, it's not that easy. Okay, but conceptually that's what we're going to do. We have to try and estimate a stream of damages and in some way aggregate them. Okay, the starting point for this though is what are those damages? What is the future physical impact of climate change on the global economy? And here I want to discuss, I'm basically going to do a little bit of a different talk and talk about the work that some colleagues and I have been doing at the Economists for Equity and the Environment, the E3 network, to try and reconcile very disparate views of the impacts of climate change between natural scientists on the one hand and some subset of economists. So we wanted to see if we can because this is an important, you'll see, a very important distinction when we think about what is the social cost of carbon. So, speaking for scientists, there's basically kind of a biblical concern about climate change. It's, it's fire and brimstone and, drought and rising sea levels, and that's that sort of collapse type metaphor. And there's some good science behind it. I mean, Hansen has done a lot of work showing that, during the last interglacial, when we were 2 degrees C warmer than we were, sea levels were 75 feet higher than they are right now. So there is good cause to be concerned about these issues. And of course, that won't happen overnight. It'll take some time for it to play out. But, and so, this is the scientific perspective you often get from scientists about the potential for real collapse of the economy in the context of sort of high-end climate change, of global warming. On the economic side, what should be the appropriate policy response to climate change and global warming? And here's where you get this distinction. And there are 2 gentlemen I want to highlight here. This is Richard Toll, who's based in the Netherlands, and Bill Nordhaus at Yale. And they have been sort of very vocal advocates of don't worry, be happy. That there really isn't much call for an immediate and serious response to climate change. So that Toll, for example, has said, let's impose a gasoline tax of 2 cents a gallon. That's his recommended policy response. Nordhaus says 13 cents a gallon. And then here's a couple of other economists who are moving more in the direction of concern about collapse. This is Nicholas Stern from the UK, former head of the World Bank, who issued a major UK government study in 2006. This is my colleague Frank Ackerman at Tufts, who's kind of been instrumental in deconstructing the work of these guys and suggesting that this number is a lot more important. Okay? So from a policy perspective, this number is actually pretty significant, and we'll see that the US government has been developing estimates of the social cost of carbon. And the basic idea is that when the EPA, right now charged with regulating carbon emissions, justifies their regulations, they do it because they say, well, if we were going to pick, let's say, a cost of 13 cents for the social cost of carbon, they'll say, well, let's impose any regulations that have benefits, that don't cost more than 13 cents a gallon. All right? And so the higher this social cost of carbon is assumed to be, the stricter the regulation that the EPA is going to be able to justify. All right, so this has very real world and important implications in the current regulatory process, in addition to being kind of the key backdrop to the work we're doing. Right? So my job was to sort of sort out which one of these numbers am I going to pick, and explain that in as effective a way as I could to the public. First of all, you can't just sum up the numbers. You have to actually do something that economists call discounting. And Professor Howarth in the back has been a real pioneer in helping us think through the right way to do this. But the basic story here is what discounting means is that if you have that stream of numbers, so that $2.80 that I'm going to get in the year 2100, or it'll cost me, the damages in 2100, can't really think of it as that high a level of damages. And the reason is that it's going to help guide my investment decisions today about how aggressively I want to reduce emissions. And as an economist, you want to think there's always an opportunity cost to aggressive investment in solar or wind. And that is, what would you do with that money if you weren't spending it on solar and wind, right? And you might, for example, be spending it on research on pharmaceuticals or on education spending. And you basically want to avoid over-investing in abatement, if you will, reducing emissions at the expense of other investments that would benefit future generations. Okay? So that's the basic logic of why you discount. And I'm not going to go into it anymore. I'm glad to talk about it in detail. But essentially, economists apply a discount rate, which you can think of as an interest rate, to that stream of benefits. Another way to say it is, is that if someone's offering to give me $10, or let's say, make it bigger, $1 million, 10 years from now, or $1 million today, the logical thing to do, if you're a profit maximizing entity, is to take the million today, right? Because you can put it in the bank and it'll grow at 5% interest or 3% interest. And so 10 years from now, you'll have $1 million plus all the interest you've earned on that million, right? So in some sense, what I'm getting at there is that $1 million in the future isn't really worth as much as that $1 million today, right? So that's the rationale. Again, another way to think about the rationale for discounting. But what's important is that the rate at which you discount things is really important. So if you discount at 5%, then if you have damages in $100 in 2100, that actually reduces to $1.20 today. So it basically wipes out those damages in your calculations. If you discount at only 1%, the damages are reduced, but from 100 down to about $41, so not nearly as significantly. Okay. Take one more stab at discounting. Another way to think about discounting is that $1.20 there, if I put it in the bank at 5% interest, due to the magic of compound interest, it would become $100 in 90 years. So that's kind of the relationship between those numbers. Okay, enough of that. You can spend hours and hours on that. Other issues, though, are how do you even get that stream of damages? How do you even begin to think about what the costs of a ton of carbon emitted today will do in terms of damages next year, or even worse, 50 or 70 or 90 years from now? Well, you need three things to begin to make guesses about this. One is you got to know how thick is the carbon blanket going to be at the given year you're interested in, right? We're now, we're at 390. We started out at 280 pre-industrial. In 2100, are we going to be at 550 or are we going to be at 880? And it's going to be very different. As I suggested, the impact of an additional ton of carbon in a very hot world is going to be different than in a mediumly hot world. Okay, so that's thing one. Thing two, you've got to figure out, well, how hot is it really going to get depending upon how much carbon we emit? And this is what's called the climate sensitivity. IPCC and others kind of have a mid-range estimate that if we double CO2 levels in the atmosphere, we will increase temperature by 3 degrees C, 5, 6 degrees Fahrenheit. But many people believe it might be closer to 6 degrees centigrade. So you got to make some estimate not only about where we're at in terms of emissions, but how hot those emissions are going to make the planet. And then finally, you get down to how much damage is done at a given temperature increase on a global scale. So you got to aggregate sea level rise, agriculture, impacts on heating and cooling costs, species extinction, droughts, water supplies. There's vast things that you would need to take into consideration. And then finally, how do you deal with, this is a mid-range estimate, right? You have one estimate, but obviously you want to have uncertainty in there. What if it gets really hot or it doesn't get so hot? So I hope I've persuaded you right now that this is not an exact science, right? And that, in fact, it's really just guesswork. It's like complete guesswork. The nice thing about being an economist is that no one can ever check whether you're right or wrong. So you can make all the predictions you want, and if it says Yale University at the end of your name, people will listen to you, whether you really know what you're talking about or not. And that's not to disparage Bill Nordhaus, who's a very smart guy. But so I'll give you just an illustration of the variance in this work. And this is really, challenging stuff. So here's William Nordhaus, who I showed before, and then Michael Heinemann at Berkeley. And this is what they come up with for the actual damages of a 2.5 degree C warming in current dollars. So Nordhaus believes that if the world was 2.5 degrees C warmer than now, we would actually have pretty small damages, you know, $6 billion in damages to agriculture, $3 billion to health, water quality, human life. And actually his biggest thing would be the risk of extreme events, which is, you know, sort of 38 billion. But if you actually exclude extreme events, he comes up with a total damage estimate of $1 billion. That's it for a 2.5 degrees C warming. $1 billion, that's all. And that's not even a rounding error in anybody's calculations in economics these days. Heinemann did an exercise where he went through all these categories and basically quadrupled them. I think many of them, in some cases more than that. So that his total, it's a factor of about 5. Yeah, 5. His total came to 123 billion. So, you know, extremely large differences there. And this is just guesswork about what would be the impacts on agriculture, energy, water, sea level rise. Here's Toll, and again, this is the guy who, remember, suggested that the optimal tax would be, Nordhaus, this is the 13 cents per gallon of gasoline kind of estimate. This is the 2 cents per gallon of gasoline estimate. And my colleagues, Frank Ackerman, broke down the model that Toll used to integrate all this stuff. And you can see that basically what Toll sees is actually significant benefits from global warming to agriculture, pretty big costs to increased air conditioning, if you will, and then virtually nothing anywhere else. And that led him to this sort of, 2 cent per gallon estimate for the social cost of, carbon. And I should say that there's kind of a neat translation trick, which is that if you have basically a $10 per ton of carbon dioxide translates into a 10 cent per gallon tax. So there's sort of a nice translation there. So this is for a total of $5.85. That would translate into about a 5 cent per gallon gas tax in this particular run of the model. Okay? So I'm going to show you an even more detailed and complicated picture here. These are the three of the models that economists have used to assess the social cost of carbon. So these are different prices for the social cost of carbon. That would be a $10 a ton of carbon dioxide or a 10 cent per gallon gas tax. That would be a $70 per ton or a 70 cent per gallon gas tax. So 3 models. This is Richard Toll's model. This is Bill Nordhaus's model. And this is a third model that I haven't discussed yet. And what I want to just show you here is kind of the range of estimates for the social cost of carbon. They range from, the mid-hundreds here at the high end to actually negative numbers here, right, in Toll's model. And what that would mean would be actually that global warming is good for us and we should subsidize it. So we should lower gas taxes to have more global warming. Why? Because it's good for agriculture in his model. That's the story. And the other thing to notice is that as the discount rate goes down, you get extremely different results from the same models. So that as the discount rate falls, from 5% down to 2.5%, the damages rise, or the social cost of carbon rises by 5-fold in this, from 10 up to 54, or from 8 up to 65. So you can see from this diagram exactly how important the choice of the discount rate is to the final social cost of carbon. So this was actually the US government's assessment of the social cost of carbon. They ran these 3 models with different discount rates. And what they ended up with was sort of a compromise, if you will, of a 3% discount rate. And they averaged the model runs, and they came out with a cost of carbon of about $21 per ton, which would imply sort of about a 20 cent per gallon hypothetical gas tax. I mean, that would be, if the government was going to impose a gas tax, that's what they would do. From the EPA's perspective, it justifies any regulation that costs less than 20 cents a gallon. All right? And the EPA has recently, for example, upped the mileage standards for cars, and they justified that on the basis of, well, it costs less than 20 cents a gallon for us to do that, so we're going to justify it. I wanted to spend a little bit of time on this sort of extreme scenario and explain why it happens. How could global warming possibly be good for us? Well, given the sort of collapse scenarios that we talked about before. Let me go back again. This is the way it happens. Basically in Toll's model, he assumes that there's really big benefits from agriculture due to carbon dioxide fertilization effects and more optimal temperatures. Okay? Now it turns out that this model basically has studies from the early 1990s embedded in it. That's the basis for the scientific basis for this conclusion. And it really hasn't been updated. And yet last year the US government used this to sort of get some numbers that they can average to generate these results. So this is really old science, for one thing, so it's wrong. And the more modern science that I just showed you from NCAR suggests, it ain't going to be too good for agriculture to have much of the United States going into extreme drought. But the other piece, and this last sort of technical piece, is that because in Toll's model, what happens actually is that the agricultural benefits are short-run benefits, right, which eventually are overwhelmed by long-run costs. But if you discount, what that does is it privileges these benefits against these costs. And so you wind up penalizing future generations in this sort of weird calculus. So I appreciate your bearing with me on some pretty technical stuff. But let me just summarize. Basically, if you take the Nicholas Stern or Frank Ackerman perspective and use low discount rates, high business as usual emissions, high climate sensitivity, high temperature damage functions, then you get a social cost of carbon that ranges anywhere from 80 to upwards of like $1,000 a ton in the more extreme scenarios. If you do the Toll-Nordhaus thing, which is high discount rates, low business as usual emissions, low climate sensitivity, low temperature damage functions, and I would add old science, bad science, then you wind up with this sort of negative or even negative to $20 per ton. So what you can see is that the EPA basically chose the high end of the very conservative perspective. That's the way they went, and that's the politics of it. As well as the economics. I mean, there is a struggle within the economics profession to define this stuff. It's not purely a political situation. Here's the range that we actually put in our paper, ranging from very low to very high. And it was interesting because this study was actually not out. No, sorry. I'm sorry. This study was not actually out, where the EPA, based on a 3% discount rate, picked a $20 per ton number. There had been previous EPA studies, and I liked one that had a $46 a ton. That was the one I wanted to go with, because it was an EPA study that was based on 3% discount rates. In this study, you had to have higher discount rates to get down to 22. And so when we were doing our study, there was actually, I got pushback from Pew. They said, we don't really want to go with this number because this number is in play. It had already been sort of discussed in a regulatory finding of the EPA, and we just don't feel comfortable straying away from a number that the government has already chosen. So you really need to use this number if you're going to publish your study. And I thought, well, this isn't very good. I mean, I don't consider that academically okay to do that because, you know, I think we should use this number. But you know, at the end of the day, this was not a paper for peer review. I mean, it was a working paper. The paper is under review. It's under review at Ecological Application, excuse me, so it's coming out. And really, I was ultimately convinced by Pew that this was, from a rhetorical strategy, that it really didn't matter which number I picked. Because whichever number you pick, you got really big numbers. And in some ways, that was the point. I mean, we didn't have to work hard to get a big number, and by being very conservative, we still had a big number, even if I didn't really feel comfortable using a number that was based on these high discount rates. So we ended up going with that. And the results were that, I think we had this table, but these were the numbers that we highlighted. So we didn't eliminate these higher end estimates, but these were the ones we emphasized. So that it was, you know, this is what we put in the chart. So we said, you know, $61 billion in damages this year, 2.4 trillion cumulative by 2050, and I think we said up to 91 trillion through Stern. So we used the full range, but we didn't emphasize the mid-range number. And so this was what we led with for the press, suggesting it could be as high as that. And frankly, for most people, there's no difference in those numbers. I mean, people see numbers like that and they go, big number, right? I mean, you know, even financial reporters. And, you know, given the degree of uncertainty here, that's really all we can say about the damages. It's going to be a big number. What press people really wanted to know from me was, well, show me these damages. Show me who's getting hurt. Give me an example. And of course, you could point right there in Iqaluit to very significant. I mean, it was really warm in February when we were there. And you know, the Arctic Ocean, the sea ice was virtually non-existent. People weren't able to hunt, weren't able to fish, so we could point to those direct impacts. But really what that 61 billion is, that's going to be the cumulative effect over 100 years of the carbon emitted in 2010. Right? It's not the damages that are done in 2010, it's the damages that will arise over time from the emissions of carbon in 2010. So this was a very kind of difficult thing to get across when we were communicating. I guess, I mean, that's the end of the story. I mean, we were successful really in getting that Arctic air conditioner breakdown story in the media, used it as an educational opportunity. The broader question about sort of reconciling the science with the economics is a project that we've been involved in. And there, we really have been increasingly focusing on sort of what does this high-end warming really mean? And Marty Weitzman at Harvard says, you know, we're really, as we move beyond, you know, 7 or 8 degrees F, we're really moving into what he calls a terra incognita biosphere. And under those circumstances, you know, regional collapse is absolutely possible. I mean, there's just no question about that. You know, we're already seeing the collapse of traditional economies in the Arctic. Continued growth, of course, is possible, and that's sort of the underlying perspective of the economics profession. But in general, we need to think about climate change investments, mitigation investments as insurance, and that's kind of a good way to bring the perspectives together. I want to end with sort of a slightly different focus, which is, I mean, the challenge is huge. I mean, you know, we're really alive at a truly extraordinary moment. It's really a crossroads in human history because we face a truly civilizational challenge. There's just no question about that. And we're also at a time of political disappointment, I think, for people who have been working hard to try and make changes in this arena. In about 1999, I sort of switched from bringing a primarily academic engagement with climate change to public education. And along with many others, spent much of the decades of the 2000s building public support for climate change legislation in 2010 that would have capped and begun to cut emissions. And I think if Ted Kennedy hadn't died, that actually might have happened. The House of Representatives passed a bill, and the Senate might have followed. But it didn't happen, right? And now there's been massive backlash in Washington, you know, a mixture of traditional conservative ideology mixed in with huge amounts of money from the oil and coal industries. And it's very hard from the perspective now of 2010 to imagine that we could possibly solve this problem, because we had a plan that involved capping emissions in 2010, having an international agreement. All of that has collapsed. I mean, the good news is that the EPA is still in a position to regulate US emissions, so the international community still sees us as credibly being able to move towards our 17% emission reduction target by 2020, although it'd be a challenge, but there's still a policy framework. So now we have to back off, and we have to think from a politics perspective. We have to start thinking, what can we do in 2016 or 2017 to get us on that glide path to 80% reductions? And so I want to invite any of the people who are under 23 or 24 in the audience next fall to come to Bard College, because we're going to start encouraging people who see themselves as leaders in the clean energy movement, either in business or in politics, to come together and really begin to strategize about this, young leaders. Because, you know, I think that you only have to be 25 to run for Congress. This is getting back to my original question. That's the way the founding fathers set it up. So I really think that your generation needs to really step up in 2014 and 2016 and run 25 or 50 or 100 candidates who are 26 and 27-year-old for Congress. While at the same time, many of you are also stepping up in the green business world to really fundamentally think about transforming the economy around sustainable principles. We're launching a green MBA in New York City in 2012, and I'd be glad to talk to any of you about that. So put on your calendar, probably around December of next year, that there'll be a gathering at Bard College of people who want to join the C2C leadership program that we're putting together to kind of self-consciously develop a cohort of young people who want to change the world. So, you know, I've been watching all these Hollywood movies, right, ever since I was a kid, and Avatar being the most recent. I realized there is a message embedded in these things, right, because it's all about these kind of people who take on the mantle of saving the world in the context of massive ecological challenges. And that's your lives. It's our lives, right? Who knew? You know, Hollywood's sending us a message. And, you know, this is really the world that we live in. You know, it's hard to believe. You know, you look outside, it looks like a normal day. But 2010 was the hottest year on record, and it's going to keep getting hotter and hotter and hotter every year of our lives. And it really falls on our shoulders collectively to figure out how to stop that and bring it down to control it, you know, because we can stabilize at 4 or 5 degrees F. And that will be a challenging world. That will be a different world. But it'll be a recognizable world. So what do you do? I mean, any of you going to Power Shift this weekend? Anybody? All right, we got 1, 2. Get your friends. Go down there. That's going to be really important. And next fall, think about joining us at this C2C Leaders program at Bard. Because we have to strategize. We have to develop a 5, a 6-year strategy to take back the government, engage both parties in dialogue about clean energy solutions to global warming, and create that national policy framework, while at the same time we're doing everything we can at the state and local level to get re-engaged. So these are my daughters. That's Emma and Liza. And Emma just graduated from college. So, you know, again, my point is 30 years goes by very, very fast, 20 years. You know, I talk about global warming and mass extinction all the time, and people say, isn't that depressing? I mean, doesn't that make you hopeless? And there really are 2 futures out there. And one is pretty dystopic. And by the year 2100, it could be 10, 11 degrees Fahrenheit hotter than it is right now. It's a post-peak oil, post-water shortage world, you know, tribalistic politics, mass extinction. not what any of us want or imagine. But I know that we're all, in this room especially, very much alive to that second vision, where we, over the coming years, do the right thing and make the investments that will allow you guys to rewire the world with clean energy and build that truly just and sustainable future. And none of us can tell which of those futures are going to come true. None of us can tell the future. But I did just finish this book. It's called Fighting for Love in the Century of Extinction, How Passion and Politics Can Stop Global Warming. And I do believe that. I do believe that collectively we have that ability, and particularly that your generation has the wisdom and the grace and the intelligence to see us through to that sustainable future. So thank you very much for having me today.
We have time for some questions, comments?
Can you just refresh my memory really quickly? Is the DICE model under the assumption of exogenous or endogenous prices?
You got a mic right there.
Sorry. Can you just refresh my memory? Is the DICE model based on the assumption of exogenous prices? Or?
Exogenous carbon prices?
Yeah. Well, just.
No, the carbon price emerges endogenously, but what are you thinking of?
Just like a CGE based. I can't remember if it's.
It has a simple intertemporal utility maximization process underway and an equally simple production process. But it is a CGE. I mean, it's a very simple CGE model.
That would also be that enhance.
Well, no, but those are parameters that are fed into the model. Those damages parameters are fed those are exogenous, the costs.
Okay.
So those are basically just guesses on the part of Nordhaus and Heinemann about what they think the damages are going to be. Yeah.
Is it possible to go back to like 1974 and come up with a cost for carbon and then play it forward and see if you can accurately predict the cost of damages from one of these storm events or maybe some of the changes we're already seeing in the Arctic?
Well, that's the attribution question. So, no one's willing to say this event is due to climate change.
But just for fun, I don't know.
Yeah, it's really a...
Make a strong point to the
Yeah.
public. I mean, I'm not an economist.
Yeah, I mean, that would essentially just involve what are the cumulative damages associated with climate change up till today. And some people have done that. I mean, there are estimates of global warming is causing this many refugees and this much cost. And again, the attribution question is hard because we're just now beginning to see the signal emerge above the noise.
So we spend a lot of time talking about how to communicate our science to the public.
Yep.
And you made this point of being very conscious of what your sort of hook, line, and sinker was for the media.
Mm-hmm.
So I was wondering if you could talk a little bit about your decision about metaphor choice,
Mm-hmm.
sort of how you rank what makes a good one and what you put into mind when you're trying to come up with that sound bite that is what you want to sell.
Yeah, I didn't come up with the air conditioner metaphor. I mean, somebody else had done that. And Pew has a communication staff, and that was sort of what they decided we were going to say. I think Scott was the one who was mostly behind that. But yeah, the choice of images is really important. And many of you probably know that it's much better to say carbon blanket than greenhouse effect. Do you know that? Oh, okay. This is classic messaging, right? Is that the greenhouse effect is a terrible metaphor, right? Because you say, well, global warming is kind of like having your car in a parking lot on a hot day, right? And people kind of understand that cars heat up, but they think, okay, well, what do I do about that? Turn on the air conditioner, right? Or something. But it's a much better analogy is to say that we're wrapping the Earth in a blanket of carbon dioxide or heat trapping gases. Because that metaphor suggests its own solution. Just like the ozone hole was a metaphor that suggests we have to fix the hole, right? We got a hole, we got to fix it. If we got a blanket that's too thick, we got to make it thinner, right? But the greenhouse effect metaphor is confusing and also doesn't really explain the problem. Because it's not, I mean, the problem is that we're building thicker and thicker. It's not even that we're building thicker and thicker greenhouse walls. I mean, you can't even get there you can't explain why the problem's getting worse in the context of the greenhouse effect metaphor. Yeah.
I'll follow up. I have not seen the 2010 NASA report yet, but then it's very, very interesting to see an attempt to assign a probability to the null hypothesis that events that we're now observing would have occurred in the absence of climate effects. But to put these two questions together, I mean, I'm wondering, you followed climate policy, I guess, for 20 years now. What's your thought about how scientists can be more effective in informing policy, which is different from how scientists get the word out about what their work is to the media, I guess? Or I'll let you go with that. I'm interested in your thoughts on that.
You know, part of me thinks that the problem is, I think we've kind of solved that problem. I mean, in that we now have pretty good tools for explaining in pretty simple terms the nature of the problem. And I mean, that frame, the way that Hansen, he was the one who reframed this, said we need to stop saying you can't blame any individual event on global warming, but, because then people just hear you can't blame any individual thing on global warming. It's a much better frame to say, well, you know, if we didn't have global warming, would this have happened? No, right? So there are framing tricks that I think are emerging that are important. But you know, I think we're really engaged now in a struggle that's much more at a kind of meta-political level, where you know, you got a group of people who either for ideological or financial reasons want to dispute the science, and so they've been muddying the waters in a sort of profound way, and so. You know, the polls show that 60–70% of the population are concerned about global warming. And that number it's fluctuated some, but it hasn't gone away. And the trick is not so much to persuade people who, for ideological or financial reasons, don't want to believe, but to keep reinforcing the underlying understanding that people have that this is a serious issue in scientifically credible ways. And what that means from a science communication perspective is, you know, just frame it in ways that people can understand when you do your press release that's associated with your study. And there's a lot of good efforts underway to engage scientists in the public policy process. You know, the folks at Stanford I can't remember. Yeah, well, yeah, Steve was a huge loss. But there's an institute, the Aldo Leopold Institute, that trains mid-career scientists to go and testify in front of Congress and be more effective advocates in that context. So, you know, scientists always face a danger when they engage in the public policy process of being attacked in the way Michael Mann and others have been. But I think Michael's shown how you just fight through this, and he's a credible scientist, and I don't think anybody in the scientific community feels he's lost his credibility. So it's just a question of being vocal and you know, communicating clearly and staying true to the facts. Yeah.
Eban, following up on Rich's question, you know, you've been working for decades. Bill McKibben, Jim Hansen, some of the people in this room have been working an awful long time, educating the public, trying to develop a movement, progress on this issue. And yet, out of the clear blue sky, the Tea Party comes along and not only doesn't educate people, but they win some votes in Congress and make a big difference. Comment on that.
Well, I think, you know, I think what happened was the financial collapse, the Obama phenomenon, this sort of amazing stimulus package, 10% unemployment, disgruntlement, disillusionment on the part of progressives and folks who cared about climate change and the political process. So, it was a whole variety of external events, and that's kind of what politics is about, right? You build a movement in the anticipation of political stars aligning in your direction, especially in the context of the American political system. I mean, it's built for gridlock. It was designed to allow organized minorities to block change. Now we have an incredibly well-financed organized majority, and they didn't come out of the blue. I mean, these folks have been around, there's been a 20-year struggle with the oil industry over these issues. So, but obviously the political victory of the deniers has been phenomenal. I mean, the last election, not a single Senate Republican presidential Senate candidate would even acknowledge the underlying science, and the House voted to overturn the underlying science. So it's obviously discouraging, but what are you going to do? I mean, the reality is it's going to get hotter and hotter and hotter and hotter. And it's going to be harder and harder and harder for that denier perspective to be sustained. And we need to build the political engagement, and ongoing, continuous, exciting, interesting, involving, so that we're ready the next time the stars align. That's really all you can do. That's really the only response you can have to the circumstances. Now, from a strategic point of view, what's happened is that we're kind of like we were in 2000, where it's pretty clear you don't really want to work at the federal level right now, other than to defend the EPA. I mean, you're not going to get any proactive policy, for the next 4 or 5 years. So you go back to the states, and you get good initiatives like we got out of California in the mid-2000s. This year, California just passed a RPS, a 30% RPS by 2020, I think. Really aggressive. And then in that process, you rebuild the grassroots, and eventually you turn your attention again to Washington when the time is right. So.
Okay, why don't we take one last question over here?
Hi, so it sounded like your talk had Arctic in it.
Yeah.
So given the growing economic development
Yeah.
that's happening in the north and
Yeah.
mining, and,
Yeah, yeah.
and that's very important to our
Yes.
economy and money talks. So are economists considering the costs involved by all this global warming in terms of companies that now the ice roads aren't open as long, so they're having
Yeah.
to ship things in or
Yeah.
having to fly things in? That's a huge cost that's now going to be, it's going to reduce profits essentially to a lot of these companies that are doing work on there. So maybe, reduction in raw material extraction, are all these types of situations being considered now?
Yeah, that's a good question, and I should have framed the talk a little bit more around that, because actually the dialogue is the reverse in the Arctic. There's a gold rush. There's the Arctic, it's opening up. There's going to be all this economic opportunity, oil, gas, shipping, right? And so the purpose of our study was to sort of reverse that meme a little bit and say, no. In fact, this Arctic breakdown is really bad, not for the Arctic people, which it is, but actually for everybody else. And Sheila Watt-Cloutier, who was at the press conference where we released the study, said, for a change, we've been telling the story of how global warming is decimating our communities. This study tells the story of how how Arctic breakdown is going to decimate the rest of the world. So we were trying to flip that kind of Arctic treasure story and say, no, a frozen Arctic is really what's beneficial for the globe. We didn't talk about the way a frozen Arctic is beneficial for Arctic people, because we were trying to tell the broader story. But clearly it is. And, in these global benefit cost calculations, Arctic economies, they're not even, a dot on an asterisk. So they just don't show up. And from a kind of GDP perspective, there probably will be a wash, because you're going to lose in some places and gain in others in the Arctic. Now, the cultural costs are. It was funny. There was an Inuit woman in the audience at our press conference, and she said, "Well, why didn't you include the values, impacts on our cultures, extinction of the animals, And it was really wonderful for me to be in the Arctic because I just never have been around a culture that's so focused around meat. It's just like, boy, that's what it's all about up there. But and it's and those things are slipping away. And I said, well, we're economists. We can't put a value on that stuff. And she said, well, if you don't put a value on it, no one's going to pay attention to it. So she really pushed back on our kind of hesitance to get engaged in that at a cultural level. So, yeah, I mean.
Sorry, I worked in the Arctic before for mining countries, so being an environmental consultant on the side, but I mean, a lot of the companies, they were seeing, Arctic roads aren't bringing as many supplies, the crops more down, so they were cutting other
Yeah, and the drilling season is,
so,
yeah.
and it can be huge, with oil prices going up, even though definitely there's lots of development happening. At one point, those profits are gonna go down, so it's trying to market it a certain way so these companies do realize that maybe their profits are gonna go down in other ways. I don't know.
Yeah, no, that's a good point.
Well, I really would like to thank Eban for an excellent presentation. It'll be available out back. His book, there's a lot of good things going on here. It's a very thoughtful, concise, passionate analysis of global warming. There's a polar bear on the cover. It's published by the University of Vermont, and those of us from Vermont, we need the revenue, so buy the book. And it's also available at a very deep discount. So it'll be out back in a few minutes, but let's thank him again.